Guess what time of the year it is, Mr. Kyle?
It's the holidays.
It is, and one of the coolest things about the holidays is toys.
I like toys.
I do too. You know why?
Because they're fun.
They are fun, but there's so much science
That's
in
so
toys.
true.
Yeah.
We should go explore some toys with science because we're talking about physics this week.
Yeah, bye.
Bye.
Last week we started talking about forces, and there are four basic forces. There is gravity, there is magnetic forces, and then there's strong and weak nuclear forces, which we'll leave for like high school or college. But force is anything that can move an object. And so we talked about Sir Isaac Newton's three laws. An object at rest stays at rest. An object in motion stays in motion unless acted on by an outside force. We also talked about how the mass of an object is going to influence force. The heavier the object, the bigger the force. Also, the faster the object, the bigger the force. Like this light little ball party pit ball may not exert much force if I throw it gently, but if I wind up and really whip it, it is going to exert quite a bit of force. And so that was Sir Isaac Newton's second law of motion. The third law of motion says that for every action there's an equal and opposite reaction. And if you don't believe that, try slapping the floor. You'll notice not only did you exert force upon the floor, but the floor also exerted force upon the hand. And that's why you're saying,
Ow, Mrs. Rainfeather, why did you make me hit the floor?
what you doing, Mr. Kyle?
I'm testing out centripetal force. It still works, by the way.
Oh, good.
Yeah, you guys remember we talked about centripetal force a little bit last week, and centripetal force means center-seeking force. And we know this is a force because nothing in our universe wants to travel in a circle unless it's made to travel in a circle. No one can take a ball and throw it in a way that makes it spin in a circle. But lots of things in our universe do spin in circles, like our planets, for instance, in our solar system. And everything around our Milky Way galaxy also travel in a circle. So if something is traveling in a circle, there is a force making it do that, and that is centripetal force. So if I take this golf ball and I have centripetal force, something tying it to the center of something, and then I throw it, I can make it spin. But as soon as I let go of centripetal force, what's the ball gonna wanna do? Is it gonna keep spinning? It's gonna travel in a straight line. Watch. Straight up, straight down. Miss Reinfeld, I have an experiment for us. So this is a bicycle tire that I borrowed from my wife. She knows I have it. But we can't break it. If we break, it's a very expensive bike. If we break it,
You're gonna be in the doghouse for a week.
yeah, something like that. Something along those lines. But this is really cool. I want to show you what we can do with some spinning forces since we're talking about physics and some spinning forces. All right? So I want you to take this wheel and turn it left and right for me. Was that hard?
No.
Very easy, right?
Yes.
Okay, but once I get this thing spinning, it's not going to want to change at all. So you're going to have to push harder on it. It's going to be more difficult. And when it's harder for you to push on it, it's going to push back on you. And maybe something interesting will happen. Should we try it? Okay, ready? We got to get this thing going really fast. Okay, try it. I'm not touching her. There's nothing moving her chair.
Oh, it's a lot harder to turn.
Is it? It's
Yeah.
difficult, right?
Yeah, but as it's turning, it's putting a force back on me and making me turn. Hey, this is kind of fun.
I bet it is. Oh.
Wow, that was a lot of fun, Mr. Kyle. That is a demonstration of angular momentum. And angular momentum is when something is spinning, it's going to exert a force of its own. And interestingly, it gives it some stability. Like in the toy, the gyroscope. which was introduced by John Bernard Foucault in the 1800s. He discovered that things stay level when they're spinning. And we can see this in all sorts of toys that we get over the holidays. Let's check some of them out.
So Foucault invented this gyroscope, and I was thinking, what is a fancy, super smart scientist doing inventing toys? Well, like we said earlier, there are a lot of toys that involve a lot of physics. And he did invent this gyroscope, and it is kind of a toy, but it can be used for lots of very scientific things, and it actually confused a lot of scientists. The way it worked is actually very, very interesting. You guys will notice that this gyroscope, not particularly stable when trying to stand up on its own. I can't really balance it on anything. And there's no like weird stuff happening here. It's just like a little spinny top inside of a cage, right? This part does not spin, this part spins, this part does not spin. And the way you move it is with this string. I'm just gonna tug on the string and get this gyroscope spinning. And now all of a sudden, it can stand up. It stabilizes itself very well.
Ooh, how cool.
It is very cool. I like this one. Run away! You could do some really interesting gravity-defying tricks with this gyroscope. You can get them to stand on the end of this side right here, just by adding some angular momentum. Hey! This one's gonna work. Oh yeah, look at that.
Nice.
That's some pretty crazy stuff right there.
Yeah, that is cool.
Another great toy we find around during the holidays is the yo-yo. And the yo-yo is a great example of stability due to angular momentum. And yo-yos have been around for a really long time. They found some etchings on ancient urns back as far as 450 AD with the Greeks. And Napoleon and his soldiers used to like to relax with the yo-yo. It's heard, just hanging around the camp. And President Nixon was known to get on television with his yo-yo. Now, a yo-yo, when its string is unwound, is not a very stable object. It turns and it swings if I move around, so it's got very poor stability. But you've seen those yo-yos that sleep on the end of the string, and sleeping means it's spinning. And when it's spinning, it's gonna catch some angular momentum. Mr. Kyle is great at demonstrating this. Mr. Kyle?
Let's give it a try. You guys see my yo-yo is spinning, and it is very, very stable. I can walk around it, I can even poke it and push it, and it won't turn in different directions as long as it's spinning. But if it slows down, then it loses its stability. And the stability of the yo-yo is why people can do such cool yo-yo tricks, because they know which direction the yo-yo is always going to be facing.
Wow, you got some moves, Mr. Kyle.
Yeah, I was a bored kid. I had a lot of time to practice. I'm not the only one with yo-yo skills. You know, Mrs. Reinfelder is pretty good too. Let's see it. Go, 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 go. Oh yeah!
I've improved this week.
So much, actually.
Some other toys that you can experiment with that have angular momentum is like a poker chip. And if you don't have poker chips, you can use quarters or pennies. And we like the game where you get one poker chip spinning and you see how many you can get spinning at the same time. Me, I'm kind of like 2, but somebody in 4B this week got 6 spinning at the same time. If you have poker chips or quarters at home and you want to see how many you can get spinning, I love a picture of it. Spinning tops are also really popular around the holidays, and they also use angular momentum to defy gravity and stay spinning. And one of the oldest spinning tops is the dreidel. And The dreidel is used during Hanukkah as a game, and it also uses angular momentum, not that one, to keep it standing up and defying gravity.
Hula hoops are another toy that only work because of angular momentum. You'll notice when they're not spinning, they don't stay up. But when they are spinning, they can stay up. Let's see how long I can keep mine up for. 1.43 seconds. I'm doing this. Okay, you give it a try, Mrs. Reinfelder. Go, 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 go. Wow, she's still going. Wow, Mrs. Reinfelder, there is a lot of physics in almost every toy.
There is, and this holiday season, we hope you find some spinning fun of your own.
Let's go find some more things we can spin.
Happy holidays!
Bye!
Bye, guys!